All right, welcome everyone to our sixth session on Chapter 6, Complex Whole. Dr. Eastman, Tim will be summarizing this chapter for us, and then we have another panel of wonderful guests who will speak about Tim's work. We have Randall Auxier and Gary Herstein and Brian Swimme. I will introduce them after Tim has summarized this chapter for us. As a reminder, you will be muted by our technical assistant and host and organizational wizard, Richard, until the Q&A at the second half of our session this morning. So with that, for those who didn't hear, I've also posted the playlist on YouTube that has all of the prior sessions. So if you missed any of them, you can get caught up. And with that, I'll turn it over to you, Tim, to talk about Chapter 6. And I'll just say that I'm thrilled to see a scientist and philosopher of your stature return to the sense of a meta-narrative to put into a kind of ultimate context our human condition on this planet Earth in an evolving universe, but a meta-narrative that welcomes multiple voices and perspectives, because the whole is greater than the sum of its parts, and no one can capture the flag. And so we need to be as pluralistic as we can in this endeavor to return to a meta narrative, but nonetheless, the importance of having some coherent story at the level of ultimate context is one that I think will be of great service to our civilization, not just to academics, but to everyday people as well. So Tim, take it away.
Well, thank you, Matt, for such a kind introduction. It sort of sets a bar that's well above me. I'm just a humble farm boy from Western Minnesota that struggled throughout a lifetime to get on top of these things, and only in a partial way, pulling together some preliminary thoughts about how to integrate and get to such meta-narrative level. I guess in part just simply to appreciate all the wonderful work done by various scholars around the world. And then what I have done is do quite a bit of reading and trying to pulling that together. And I'm not always very good at analysis, but in some ways I'm fairly good at synthesis. And so one thing that I have been increasingly dissatisfied with in the past number of years is just the standard book you see in the bookshelf by physicists that explain where we are with our very latest understanding. And having in hand here a book just from last year by Brian Greene entitled Until the End of Time. And he makes much of how, the many worlds interpretation of quantum physics and multiverses and that kind of way of understanding things is somehow the way we now see things based upon contemporary science. And I look at it and think, well, gee, this is just an example of actualism, of presuming that, so to speak, all the possibilities, the different alternative outcomes of quantum experiments then somehow are put into actualized whatevers, and then we wrap those all together into a many worlds interpretation of to then satisfy all the epistemological statistical kind of descriptions, all put into a substance like space-time wrapping, and then on a cosmological level thrown into multiverses and that kind of discussion. And I just find all of it kind of running down a track that I find unsatisfying. So what's the alternative? So about 10 years ago or so, well, actually somewhat more than that, about 15 or so years ago, I got more and more exposed to some of the implications of the new quantum physics, but in ways that are somewhat different than the standard description. And I think more recently influenced by the work of Michael Epperson and Elias Safiris in their excellent book, Foundations of Relational Realism, which brought together the new possibilities of understanding through new developments in mathematics called category theory and understanding interpretations of quantum physics that led them to the ability in a work of 2013 to be able to effectively interpret every known quantum experiment in a way that made sense. And this was, I think, a breakthrough because no other interpretation enabled that kind of integrative framing. So then I looked at that carefully and read their book once, not once, but twice, and tried to figure it out for myself. And then that led me to thinking in a new way about the fundamentals of things, not just scientific, but philosophical. Let's see. Then, in addition, well, let me just take a side note here about the standard narrative, so to speak, that I mentioned that so often gets not just the multiverse kind of description, but also the presumption that at the cosmological level, that the Big Bang is kind of like the given narrative, you know, the grand universe story as being the only way to understand things. Well, I think a lot of progress has been made in space science and astrophysics, and I think a lot of it's very well grounded and very well vetted. But as you get to increasingly large timescales and increasingly large spatial scales, things get ever more dicey. And this is true whether to larger scales or to exceeding small scales. It gets ever more difficult for us to really test things adequately. And arguably at the exceeding large scale, cosmological science has, so to speak, gotten so dependent on theoretical description and models that it's to some extent gotten decoupled from the ability of experimental test in any way, or even observational test, even though certain claims are made for such test. More recently, within the past year, I've been a contact of mine, a scientific contact, Eric Lerner, who's done some work in cosmology, who currently is very much primarily involved trying to work the possibilities of focus fusion as a new approach to fusion to complement other efforts towards potential long-range energy sources. And I think it's a very productive route. Nevertheless, at the same time, he's gone back to look at some of the cosmology issues from a new perspective. And he has a as yet unpublished paper that I have in hand. I hope to see it out in the coming few months or so. But he looks at systematically a reanalysis of the data over the past 20, 30 years related to physical cosmology, and shows that in the almost 60 years after the Big Bang was proposed for the origin of light elements, and indeed some 80 years since the hypothesis of the Big Bang, that then of course was ridiculed by Fred Hoyle, you know, the Big Bang, right? And then of course the early predictions were shown to not work out, and then they modify that, and eventually, but then, so it looks very promising as an hypothesis right up to the end of the century, the Big Bang approach. But it's increasingly after around 2005, there's been a substantial divergence between prediction and observational results. And Eric reports that in this time that observations have increasingly diverged from the prediction of the Big Bang hypothesis for helium and lithium abundances, leaving only deuterium as a correct prediction, or at least nominally correct. The Big Bang's hypotheses, other predictions have been abundantly contradicted by at least 16 data sets, Eric reports, with divergence between prediction and observation steadily increasing with time, especially after 2005 to 2010. Other than deuterium abundance, he reports the Big Bang predictions are in accord with no major data set. The observations taken as a whole clearly exclude the hypothesis of a hot, dense Big Bang phase of universal evolution. He concludes the Big Bang never happened. and includes instead, we should be open to how at galactic and stellar scale there can be the evolution of elements long term that can actually provide a way to understand the current measurements of light elements, and indeed the predictions appear to be in excellent shape with respect to such argument. So we'll see. That would be a major adjustment, but that we shall see. But you see, some of these questions, because my field is space plasma physics, I've often been in touch with plasma astrophysics people that work some of these issues. And whereas cosmology in the past half century and more has appeared to be effectively isolated from applications of technology, which is typically the way that you really get a confirmation of a certain scientific approach. For example, the validity of Maxwell's equations is demonstrated every time you turn a light switch on, and quantum mechanics is demonstrated every time you look at a computer screen. And the effectiveness of new paradigms and technology and their application, their direct application, help drive acceptance. But unfortunately, physical cosmology, because it's so remote and it's so difficult to provide effective testing, has appeared to be effectively isolated from such applications to technology. While discoveries in astrophysics in the past have obvious implications for technology, such as the discovery in the 1930s of nuclear fusion as a source of energy with stars, no central link for cosmology are widely recognized today. The real links that do exist between plasmas in the cosmos and those on Earth are unknown to all but a few researchers in plasma astrophysics, which is not the area of expertise of the field that are mostly working in this area. So the possibility of paradigm change demonstrated by technological advances has been much neglected. So anyway, I set aside all of that, and indeed I argue in chapter 6 that with respect to the bigger picture of things, that issues of physical cosmology as such I don't depend on that. I can kind of set them aside, and I need to set them aside because I have real doubts about the standard narrative. And indeed, Randall Auxier and Gary Herstein likewise raised serious doubts about that standard narrative in their great work that will be discussed by Randy and Gary shortly. So, what but what I attempted is just a clean slate. Just looking at various sources and looking at them, reflecting on them. And then looking at these results in quantum physics and interpretation, the quantum physics results that were so well summarized by Epperson Zafiris, but also by Ruth Kastner, who has previously been with us to explain her possibilistic approach, which is an excellent understanding that's highly compatible with what we've discussed. That at core, that we think about what is the core notion, and I think that's what was also brought up by Whitehead over 100 years ago, that reality most inclusively is both the actual and the possible. Again, reality most inclusively is the actual and the possible. And how that comes out in the quantum physics description, and Epperson Zafiris laid this out, that you have the succession of the fundamental quantum process from the initially then a multiplicity of possible states and a transition to a selection among those possible states given the constraints of boundary conditions, initial conditions, and the possible states for a given condition. And then you have the actualization of a particular outcome from that finite set of potential outcomes. So there's a transition from the radically possible, unlimited, to within the constraints, a certain potential set of outcomes, to a specific actualization. And then this is a process ingredient to every actualization in the universe at without limit, let's suppose. I mean, that's the implication of this new science. And then in turn, let's say that we hypothesize that that has a corollary with the reality most inclusively. And I think also it is a correlate, is a counterpart in our own immediate experience. That is, our own immediate experience is that of, well, possible outcomes upon how we respond to our environment, respond to given inputs, and then there's a selection among those outputs and a certain actualized definitive result. So then, after Zephyrus, and Zephyrus being the mathematician who works out the category theory, there's the inference then of a distinction of two types of logic. What he described as a Boolean logic, a logic that is that for a specific outcome, like we ask whether the electron spin is going to be up or down, it has various possible orientations, various possible outcomes. It could be up or down, whatever, but upon measurement, it's actualized and it really discretely will be either up or down, either 1 or 0. It's digital. We talk about digital computers. They're going to have a particular state, and you correlate those particular states. And there's great power in just such a binary dual, so to speak, Boolean construction. Boolean logic is the foundation of computers. And yet in the quantum physics, you have both that reference to the discrete outcome and their correlations and this range of possibility. And so what I argue in the Logoi framework is that, well, let's take this distinction of the actual and the possible as part of the real, really take it as foundational. That is, I hypothesize that this has a fundamental order, that there is I then make a claim that there's a fundamental order of the orderings of possible relations, of possibilia, distinct from the fundamental order of actualizations. And this has it's a succession that our time-space descriptions of things, of outcomes, are the outcomes of fundamental process. That what is fundamental is the process, as Whitehead described, and that process is always a matter of the transition from the more open-ended logic of potentia to a logic of actualizations, and that these are coupled by virtue of every event, every process in the universe whatsoever at multiple levels. But then you see, I've just introduced here these two orders so far: the order of potentia, order of the actual. And you might argue that, so to speak, the order of the potentia is integrative. That is, it's reflected in the quantum entanglement phenomena. It's radically inclusive. It transcends space-time limitation. It pertains to pre-space. And the order of actualization is radically pluralistic. In a way, you almost have the monist pluralist kind of contrast right there. Right there in every ingredient actualization whatsoever is this succession from the order of potentia with its integrative monistic entanglement kind of whatever in the pre-space mode to actualized outcomes, which are discrete, radically pluralistic. Then I kind of work out, well, what's the implication of that? And I argued in the chapter 4, where we went into causation and emergence, that then if you take that essential kernel and then you argue that multiple levels, that you had sets of relations that link into one another at multiple levels, that if you look at that fundamental process with an eye to the a synchronic framing at a given time, then it's multiple levels in kind of the conventional sense of small to mesoscale to macroscale and so forth. But if you focus on it in terms of a diachronic across time, then that's fundamental causation. So to speak, the fundamental process of what I've just described, that fundamental quantum process, if you take different perspectives on it, voila, then you have the distinction between emergence, multi-scale emergence, and fundamental causation, both coming out of the one fundamental framing. And that's, so to speak, the essence of my hypothesis about the Logoi framework. And from there, other things come out, but it's not, say, building on Whitehead or Peirce or any other particular framing to start with, except for these inspiration from quantum physics and my immediate experience and hypothesizing something that is compatible with that description, and then coming back, then working through it and saying, aha, this is interesting because now I have a new way of understanding a number of features. And then it turns out later on that a number of these features have a consonant with the efforts that, for example, Randall Auxier and Gary Herstein also wonderfully formulated about the, in their work about the notion of actual entities of being of any scale. Well, that's perfectly compatible. In fact, that's very much expected by the multi-scale synchronic perspective on the fundamental process. It's multi-scale necessarily, and yet you've got the diachronic causal kind of description coming out, and a subset of that is, so to speak, efficient cause. But at the same time, you have other kinds of ways of framing the notion of cause that then could lead even to the Aristotelian distinction of the four types of cause. Indeed, even formal cause. Let's see, then in chapter 6, I took different elements of, so to speak, consequences of this and laid them out. But I think now, in terms of my description, well, let me just simply review one thing that I do have in the chapter without, I don't want to take too much time here. And I have a concise summary, just taking certain elements of the chapter and putting them into a concise summary. Do look for that. So I then summarize the fundamental ontological and epistemological factors, which I then arise out of this elemental start that I have described. The fundamental ontological factors being that there's a mode of being and becoming, both the contingent and the non-contingent arise out of this. That you have these fundamental logical orders that I mentioned, potentia and actualizations, the Boolean, the non-Boolean, and the Boolean. Third, an extensive connection prior to metrical relations, which involves local, global, and as elicited by the category theory approach. Fundamental quantum process, including both the diachronic process that correlates with Whitehead's discussion of prehension, Jorge Nobo's discussion of succession, symmetry breaking, causation, actualization. And then also with a synchronic focus, emergence, multiple levels with grounding, semiosis, the triads, triadicity. And I talked to chapter 5 about the basic semiotic approach that comes out of this. Then the fundamental epistemological factors being the mode of perception, presentational immediacy versus causal efficacy, as Whitehead described, the physics and semiotics, and the ways of knowing, the way of numbers, which especially is correlated with the scientific orientation, context independent, or context focus, which is then with the triad input, output, context, semiotic orientation, and ultimate context, which I then ultimately will frame in chapter 8 to the spiritual dimension. With that, I'll wrap up and look forward to inputs. Thank you.
Thank you, Tim. So we'll move now to our panelists. I'm going to go in alphabetical order. So I know Randy is here. Gary is here as well now. Yes, great. So first we'll hear from Randall Auxier, who's a professor in the communications department at Southern Illinois University. Randy has been contributing to the understanding of Whitehead and process thought for many years. He has a number of new books out that I'm eager to take a look at, including one on logic, one on the metaphysics of movies, another on a title that I really like, Persuasion, the Real Process of Imaginative Thinking. That sounds very interesting. But of course, the book that Tim is drawing on mostly in Untying the Gordian Knot is The Quantum of Explanation, which Randy co-authored with Gary Herstein. So before we hear from Gary, we'll hear from Randy first. We're going to take about 10 minutes each, and the floor is yours, Randy, please. You should be unmuted already.
All right, can you hear me? All right, so first thing, I'm in the philosophy department and communication studies department at SIU, so I haven't wholly left philosophy behind, although I have to say that in the same way that Tim is sort of disappointed in what happens in the academic physics departments, I'm pretty disappointed in what happens in the academic philosophy departments, and have had a hard time increasingly as my career has gone on to sort of stay in that conversation, which I regard as increasingly irrelevant to anything that really might take anybody forward. But anyway, I want to thank Tim first and foremost for his sympathetic treatment of our ideas in his book. He made reference to a couple of other of my writings as well, and I appreciate that. And also to Gary's, which I assume he'll talk about, independent writings. And so generally speaking, he got us right, I think. I very much appreciate being included in these synthetic efforts that he's undertaking to take process thought to the next stage. And I think Tim has really succeeded in what he set out to do. So I wouldn't have thought it possible to do what he has done, because what I've always done is attended to the differences between my views and a lot of the views that that Tim summarizes. When I'm reading somebody I really like, and Epperson and Zephyrus would be a good example of this. I'm going, yeah, that's all right. Everything's right there. Yeah. Oh, but look. and so I have a tendency to zero in on the place where I think there's some disagreement for two reasons. One is because I think that's how I make progress in my own thinking is here's a place we disagree. Now, are they right? Do I have something I need to learn here? Or am I pretty sure that once I've understood it, that I want to move on? But anyway, Tim has attended mainly to the overlap of what? I mean, it couldn't be less than 100 people who get synthesized in this book. And just when I think, just when I think I've heard of everybody who's doing interesting work, Tim digs up somebody else who has said to somebody I didn't know about, who was doing really interesting work. So so paying attention to the overlap, doing an amazing job of seeing where the complementarities produce a viewpoint that he can defend on the basis of both his knowledge and his experience. And I want to emphasize my appreciation of his willingness to include personal experience in this book. There was some, just a few nice moments of that in chapter 6. But it's, it's spread throughout the book. I regard it as incredibly important to humanize this stuff because it's for humans after all. So after favorable reference, so I'm going to go into a couple of technicalities now to the work that Gary and I have done, particularly our central idea of the quantum of explanation. Tim explains as follows. So I'm quoting Tim here. For such systematic philosophy as we are doing and as he is doing, at a metaphysical level of description, generalizing actual entity or dynamic particular in Hartshorne's work to a quantum of explanation instead of some exemplar of metaphysical events results in a productive reinterpretation of Whitehead's work compatible with the Logoi framework, this of course being Tim's view. This is because it explicitly builds on a theory of relations grounded in a topological framework in contemporary scientific parlance, so that's category theory, and algebra of relations that highlights both fundamental quantum process via the Whiteheadian concepts of prehension, concrescence, and transition, and extensive connection, and which incorporates pre-space local global connection. So in quotes, so what Tim is saying, this is pretty dense language, but it's easy for me to follow because he's summarizing something, something that I know pretty well here. And so I have to say, this is a really good way to look at what we were trying to do with the actual entity, and it is gratifying to be understood this well. But there are a couple of minor things to correct. One, we don't compare the actual entity to Hartshorne's dynamic particular. And I wouldn't accept a substitution there. Hartshorne actually believes in little bits of reality, and he has a sort of a compositional view. He also always admitted freely and openly that he didn't understand the quantum theory, and he lamented it. I've written extensively on Hartshorne, and I get a lot out of the study of his thought. And I spent a lot of time editing some stuff that he wrote and whatnot. So in no way am I setting him aside, but the dynamic particular is definitely not what we're getting at with the quantum of explanation. And the quantum of explanation, as Gary and I tried to do it, wasn't supposed to be a generalization of Whitehead. We were trying to get Whitehead right. And we think we did. However, I have to admit that might not be the most important part of it. Whether it is right or isn't right as an interpretation of Whitehead, the idea, I think, is probably more important. I just don't claim ownership of the idea, and I know Gary doesn't either, because we think this is what Whitehead was saying. But anyway, it leads me to wonder. So Tim acknowledges on page 205 that he knows we take ourselves to be interpreting Whitehead in this. And he contrasts us with Richard Campbell's and Johanna Seitz and Randy Deipert's views. And he seems to see these alternatives, all of these as alternatives to the narrow readings of micro reality that are essentially relationalists. So in other words, mine and Gary's view is just one of several choices you have if you don't want to take the microphysical particle as some kind of ultimate constituent of reality. And I definitely agree that relationalism that does not base itself on some substantialist or actualist view of micro reality is important. But I wonder, Tim, how comparable all these views, so I mentioned Campbell's and Seitz and Deipert, how compatible they really are with one another. You're so busy synthesizing that sometimes I wonder whether the incompatibilities have been set aside. And I really want to hear what you have to say about this. And so there's real differences with our framework and the other frameworks that Tim examines. And he does a really good job of letting each view, this is one of the things I love about this book, he really lets each view speak for itself. I know many, not all, but I know many of the authors that he talks about quite well, and I'm always impressed. He seems to get everybody right, and this is some pretty difficult stuff. Sometimes, so for example, his interpretation of James Bradley really helped me because I knew James Bradley was right about everything, but kind of putting it together was something I had not been able to do, but Tim does it. So here's the question, surveying the available ontologies, We offer ours as a way of moving forward without losing anything from what the other people have done, at least anything that could be saved. So Gary and I see our framework as actually including Epperson and Zephyrus, and is including yours, although we didn't know it when we were doing it, because what we're shooting for is something that is as general as the Big Bang Theory. I was really glad to hear your remarks at the beginning of this, because I doubted the Big Bang Theory the first time I ever heard it. I thought, oh, no. If I want a story about the creation of the universe, I prefer the universe as a green dragon to this, because it does not do away with the humanization process of our narratives that we need in order to make sense. And of course, Gary and I are telling stories. I think physicists just need to admit that there's a storytelling element to this. And Gary has a nice way of talking about it. He calls this the demand of narrative intelligibility. And I think it's as important as the accretion of value, which is the other thing Gary likes to use to describe. I'm not stealing your thunder, Gary, because I'm sure you're going to talk about the measurement problem. But anyway, maybe we haven't discussed this in advance. But anyway, in a way, getting Whitehead right is, we believe, the way to go forward, because we think we haven't really caught up to Whitehead. I would say the same thing about Peirce. I haven't had that discussion with Gary, but I don't think we've caught up to Peirce. I think these guys are still possibly 50 to 100 years ahead of where our theoretical cosmology, and that includes the scientific aspect of it, has gone. And so I think there's still reason to go back to the original text of Whitehead and be sure we've got it. So Tim's point about the compatibility of what he's doing with what we're doing, I accept that fully. And I think that if you aim to synthesize all the cutting edge work that's being done, then he's done that. I mean, he's just succeeded in doing that. I'm going to skip down a little bit in my prepared remarks here. But I don't actually think that what Tim is doing, what he's done is he's clarified a whole world of territory that Gary and I just skipped over. Because what we wanted to do had a lot to do with theorizing. Almost everybody who builds on Whitehead dumps eternal objects or God or both. And Gary and I don't dump either one. We understand the role of eternal objects and God in Whitehead quite differently from the way anybody else we know of understands it, although there are some other Whitehead scholars whose views really, they overlap with ours in various places. James Bradley is certainly one of them. But anyway, I don't know what Gary will say, but I have a devil of a time getting anybody to understand what I'm talking about when I talk about the theory of possibility. Tim and Matt and John Cobb and several of us have had a bunch of emails back and forth, and I still fail to express myself clearly enough in order to get what I'm saying across. And I've got this nice quote from Whitehead. It may be that I'm just wrong and crazy, but it may be that if there's any possibility that Gary and I took a step forward in especially physical cosmology, but remember, the physical aspect of cosmology is only one part of cosmology. And so we look at it as being a part of a much larger framework. It involves physics, but it transcends it. But anyway, Whitehead says, human life is driven forward by its dim apprehension of notions too general for existing language. I feel like what we are doing with possibility might be right and our notions are just too dim. It may be, but Whitehead continues, such ideas cannot be grasped singly, one by one in isolation. They require that mankind advances in its apprehension of the general nature of things so as to conceive systems of ideas elucidating each other. But the growth of generality of apprehension is the slowest of all evolutionary changes. It is the task of philosophy to promote this growth in mentality. So I hope that Gary and I, with our theory of possibility, that we are actually pushing things forward just a little bit. I don't think that the Logoi framework aims to do that, and I don't think it actually does that. I think that what I want to do is learn from the Logoi framework so that I can get better at explaining what I mean by possibility and the kinds of relations that are involved. And I think it really, really helps. In a way, this book, it does a lot of the things that we just skipped over in order to go straight after the key to what we were thinking, which is this idea of the actual entity as a quantum of explanation. It is true that we think that that was Whitehead's original idea, but we also think that it hasn't been fully understood and that it's part of a complex of ideas that includes creativity, God, and the eternal objects and prehension, especially fundamental relatedness, whatever you want to call it. This complex of ideas we don't think has been thoroughly understood yet. And so as our ongoing work proceeds, I know I am, and I think Gary is too, we're trying to push that boundary with our dim notions. And of course, I can't explain what possibility is from this point of view in today's discussion, but some of it has come out in our previous discussions. And so I refer back to it and I say, but Tim aspires, and nobly so, to synthesize person Whitehead. And speaking as a scholar of both, I don't think he has yet come close to doing that. That is too much. Person Whitehead, you're just taking on the two most incomprehensible and prophetic philosophers of the last 150 years, and you're going to synthesize them. Oh my God! But you've got to start trying, and nobody tries to do this because Peirce in and of himself is so difficult, and Whitehead in and of himself is so difficult that the idea of even diving in to a synthesis of Peirce and Whitehead. But I think he's got a bunch of stuff right here, and I learned a lot from it. So I want to thank Tim for that, and I will be interested to hear what he has to say about the differences, not just between mine and Gary's ideas and these other people, but all these people who get synthesized. How do you differentiate when you're so good at synthesizing? Okay, so that's what I have to say.
Thank you, Randy. Well, I can definitely confirm that my sense of the many things I only dimly apprehend has grown tremendously throughout these sessions and reading Tim's book and reading your work. Don't give up trying to communicate your understanding of possibility. I think our mentality will continue to grow as a result, whether or not you are right? So,
I might be wrong after all.
So let's, thank you so much, Randy. Let's turn it over now to Gary Herstein, who is, after a career as a computer scientist in some high-tech industries.
Not scientist, not a computer scientist. People always get that wrong.
Engineer?
I was a technician.
Technician.
I was a computer technician, not a computer scientist.
Got it. So you had a successful career as a computer technician, went on to write your, I believe it was your dissertation on Whitehead and the measurement problem of cosmology. Yep. And then, of course, with a number of other publications, including in an edited collection that Randy co-edited on Bruce Springsteen and philosophy. But you're also the co-editor, of course, of Quantum of Explanation. And so we are all eager to hear your contribution to this important conversation. So take it away, Gary.
All righty. To start with, my only copy of Tim's text is an older PDF file. My pages are completely wrong. So when I quote something, I'm not even going to bother giving the page because it's completely wrong. The reasons for the older PDF, we can get into that later, but they're not really relevant. And plus, my discussion is likely to be significantly colored by my cats introducing themselves. So be patient with that. So I want to skip to the stuff I want to talk about is actually a little sort of tangential and sort of not. So I'm just going to jump in. I'm going to have a few brief comments about quotes that I won't give a page to. And then I'm going to get to the thing that I really want to talk about, which no one expects me to talk about. So to begin, the chapter is supposed to, oh, and also I don't have prepared remarks. I have a 5-page outline. This chapter is supposed to be about complex systems, but it says almost nothing about complexity per se. And it's going to be the thing, and it's going to be talking about complexity that I want to ultimately get to. So I'm going to skip through the quotes fairly quickly because the thing, and then get on to the stuff that I wanted to. And my other thing I'm note off to the side, which is why I'm staring off to the side and not at you. So first quote, this is because it explicitly builds on a theory of relations grounded in real topological framework in contemporary science parlance, category theory, and algebra of relations. Now, Randy already quoted that line within a larger quote, but I want to focus upon precisely that bit. Whitehead's myriotopology should not be so quickly identified with category theory. They can work together, but they are also run in independent directions and typically have run in very independent directions. For example, most work in category theory is aimed at joining it at the hip with set theory, not myriology or myriotopology, which is frankly quite antithetical to NW's myriotopology. Set theory in all of its basic guises has minimal elements called elements. You have a relation that specifies that alpha is a member of the set X, which along with traditional logic provides all the basic machinery of set theory. There is, I don't need, I can skip that. This is what is what the overwhelming majority of workers in category theory do. They work to make category theory an adjunct to set theory, not an independent structure. I mean, Lauxier was the most famous person who tried to make category theory an independent foundation of mathematics, but his work is almost entirely skipped over these days. So set theory is not Whitehead's myriology, much less its myriotopology. NW works is what has come to be called atomless gunk. That's true story, that's a technical name. There are no elements in Whitehead's myriology and of any kind. There are no minimal units. And by the way, Randy and I made a very conscious effort to avoid any set theoretical terminology throughout quantum of explanation. So we incorporated terms like constellation, collection, but never element, member, set, class. We did our very best to avoid using any of those terms. So category theory can work with this, but it's not required to. It does not automatically go there. So that's the first part. I mean, caution with making too automatic an association of category theory with myriology or myriotopology. I mean, it can go there, but almost no one takes it there. For example, quote number 2, for example, Einstein's general theory of relativity is often laid out as sheets of space-time substance with discrete properties at each space-time grid point, which then constitute a convenient basis for mapping to computer simulations. However, although very useful for modeling purposes, such simple mereological part-whole linear causal frameworks are inevitably incomplete, simply objectual approaches to levels of reality. Once again, this is more specifically set theoretic and not mereological. Real analysis in point of fact, so to speak, because real analysis deals with infinitesimal points. Einstein and GR work explicitly with infinitesimal points, which Whitehead rejects as early as principle of natural knowledge as mere abstractions and not actual basis in reality. Points are set theoretic elements, not mereological parts. Again, set theory and mereology need to be properly separated. Set theory necessarily presupposes minimal units, which mereology does not do. I have a long list of historical sidebars. I will skip over. Part B4 in the outline that I sent to Matt and Tim, I realized that I had just completely misread what Tim said. So I'm going to skip that entire section altogether unless Tim insists on saying that I'm mistaken about thinking I was mistaken. Let's see. Quote, as Bradley points out, the significance of Peirce and Whitehead resides in their defense of speculative reason against its critique by continental and analytical philosophers alike. Another historical sidebar, just because this always interests me. The distinction between analytic and continental philosophy did not even exist when Whitehead was writing his principle, process and reality and earlier. It only began to emerge after the debate at Davos between Martin Heidegger and Ernst Cassirer in March of 1929, which, by the way, was also attended by Rudolf Carnap. So this doesn't really affect what Tim says. It's just always interests me. For questions of psychic phenomena, he talks about this. I don't have any exact quote, but I do have some cautionary notes. Bear in mind, for example, the Occam's razor issue. The professional magician, the great Randy, has a wager, still standing wager. Anyone can show an example of psychic phenomena that cannot be matched or beaten by a professional magician. He'll pay that person $1 million. Now, he has specifically trained young artists to go into scientific centers that were supposedly studying a psychic phenomenon and did the Uri Geller bent spoon phenomena, fooled them all completely. Scientists are not good at picking out good magicians. I mean, I'm not sure any of us are, except for other good magicians. But I mean, completely fooled them, just flat out stumped them. They thought they had a real thing here. More Uri Geller's bending spoons. They were faking it. It was all faked. And so, a thing to keep in mind when you talk about science, about this stuff, is that there's nothing here that's really stood up to critical examination. But there's a second caveat I want to add. Just because I can sail across the Atlantic Ocean in a boat does not prove wrong or false someone who says they flew across the Atlantic in an airplane. I mean, if I don't know about airplanes, then I might find a claim to have flown across the Atlantic extremely dubious. But just because the one happens doesn't mean the other isn't true. Just because the one is a simpler explanation doesn't automatically make the other false. Just makes it in need of greater amount of evidence. The word plasma, I wanted to add that Tim mentions how the word plasma doesn't even get mentioned in much of the current and contemporary, both popular and technical physical literature. I mean, in fact, one thing that struck me was that Hawking's book, The Large-Scale Structure of Space-Time, which, by the way, earned him the Lucasian chair in physics at Cambridge, doesn't say a word on the subject. Doesn't say a word. I mean, that's how absent plasmas are from physical literature. Hawking must be the last guy in physics to actually write a full technical peer-reviewed book on physics. Everybody else only writes articles and research papers. And of course, Large Scale was from 1975, but still, I mean, that's how absent the concept of plasma remains, and that has always been from the physics literature. Finally, the phrase multiple perspectives on the whole gets repeated throughout many places throughout the text. And a couple of questions that jump to mind, and this is going to help segue into the stuff that I really want to talk about. And I just don't want to, trample over the time too much, so that's why I'm rushing. Question number one comes to mind. Do potentiae outrun the possibility of scientific consideration? The reason I ask this is because obviously we don't need many worlds twaddle. I mean, the many world stuff, I have no respect to that, especially in physics. I mean, it's silly in philosophy. It's a barely useful tool in formal logics, but in physics, it's inexcusable. But even with within the narrow boundaries of technical modal logic, turns out that modal logic is uncomputable. And I'll say in a minute, when I get to the stuff I really want to talk about, a little bit more about what that means. We need to talk about computability because there's a reason to believe that an uncomputable theory is not and cannot possibly be scientific. Because it would be empirically vacuous. Specifically, the set of computable theories, by the way, is strictly smaller than that of the total possible theories. Smaller in the way as the technical term is measure zero. It's so much, the number of computable theories is so small, even though it's infinite, is so much smaller than the total number of theories that the odds of stumbling into one by accident is non-existent. And even theoretically computable theories are of no value unless they are also within some margin or other tractable, either computable in some realistic sense, which is why we must have a serious discussion about complexity, because something that is too complex also cannot be scientific. At this point, I might add, at this point, I want to oppose what might seem to be, at first blush, to be an outrageous notion. Is complexity a matter of external reality, or is it, scare quote, just a matter of our theories? Bear with me here. Thing about complexity, is that it is not simple. When we speak of complex systems, it is easy to assume that we know what we're talking about, but those assumptions are typically either wrong, oversimplified, or badly misdirected. So what is complexity and where is it? Some examples from nature: water running downhill, the weather. Determining whether a problem can be verified after a solution is generated is equivalent to one for which a solution must be generated in the first place. The latter is a problem from computer science known as P versus NP. The first two involve intractable mathematics, nonlinear mathematics. But the thing is, nature just goes out and does it. Nonlinear mathematics pops up everywhere. Again, so the weather example. That's why we cannot come up with a computer model of the weather that goes out more than 5 days, because the nonlinearity, the reality diverges from the reality, because we can't take account of all of the factors that are involved, inconsequential differences in initial conditions, and you get wild differences some short period down the road. Another example of nonlinear, Newton's theory of gravitation, perfectly deterministic, absolutely deterministic, but as soon as you have 3 or more bodies interacting, it becomes nonlinear and fundamentally down the road unpredictable. I mean, short term we can do all right with our predictions, and we prove that all the time with our space probes that go out, and the accuracy of the navigation of the Voyager spacecraft was once compared to threading a needle, the eye of a needle in New York, with a thread starting in Los Angeles on a single toss, and threading that needle across 2,000 and plus miles, and yet go far enough down the road, and all of our predictions about gravitation, about planetary mechanics, they're going to be wrong, because it's nonlinear and we cannot predict that far. And again, we can't calculate it. The universe just does it. The universe has no problem putting the planets. The universe has no problem putting the weather out there. The universe has no problem the water running downhill. A fellow I knew back in the 1980s when I was living in San Francisco once suggested that one way to think about it is that the smallest computer capable of calculating a nonlinear process, a process modeled by nonlinear equations, I should get my language correct there, is the entire universe itself. Anything smaller than that cannot be accurate enough. Part of the problem is what I call a logic engine versus a dynamic process. I mean, these are my terms, don't try to look them up anywhere. I had another example, how a computer plays chess versus how a human plays chess. This is an interesting example, and I'll come back to it in a moment. Whitehead and fact. Now, like I say, the universe just does this. Whitehead in Concept of Nature talks about fact, factor, and object. Fact is simply the entire universe all at once. The term I use often enough is a tsunami of reality, just boom, hitting you all at once. Fact. It is the one most concrete thing out there. Everything else is an abstraction from that concrete reality. So he has the idea about factor and object are progressive abstractions from that. Objects as enduring substantive things are one of the higher levels of abstraction out there. And they're abstraction, but they're abstractions of real characters. I mean, he is a realist, but the abstractions are just that, they're abstract. They're not the concrete things from which fact is built. They are the abstract things that are derived from fact. And then one more example, a Zen meditator, someone who's good at meditation, goes out in the middle of calming the maelstrom of thought. Everything is fundamentally simple. You go out in a meadow and you sit down and you meditate. From a scientific perspective, what could be more complicated? All the biology, all the neurobiology, all the external environment, the light, the energies, what could be more complicated? Yet for the person doing the meditation, what could be more simple? These are examples to kind of pull out the notion that maybe the complexity is a problem of theory, not of fact. Now, of course, Whitehead doesn't use this discussion of fact to or make any arguments, as far as I know, about complexity, as I am bringing the suggestion here, but he does at least lend himself to the suggestion that maybe complexity is a problem of theory, not of reality. Reality just does its thing without any permission from us. It's only we who have trouble trying to calculate the logic engine. And there goes one of the cats, the logic engine aspect, where the problem or the difficulty pops up. So, I mean, there's a space to view here complexity as an emergent, quote unquote, factor of abstraction. And of course, I use that term advisedly. Complexity itself, from computer science, there's a question of there are solvable problems and there are unsolvable, computable or uncomputable problems. Not even infinite resources will solve an uncomputable problem. I mean, God herself could not solve an uncomputable problem except by cheating and basically legislating an answer. Solvable problems then break out into problems that are solvable in theory and those that are actually solvable in practice. The first are called, the ones that are only solvable in theory are intractable. The tractable ones that can actually be solved are ones that we can actually work out a solution to. These are known, this is the theory of complexity, in breaking out all the different layers and hierarchies of problems that can be solved using given finite resources, and how likely are you to actually reach a solution. So this is the tractable versus intractable question. Solutions versus verifications, my earlier comment. It's a well-known problem in computer science, in complexity theory at least. A solvable problem that is tractable can be solved with a degree of resources that can be calculated with a simple polynomial equation, hence the P. And this is generating a solution from the ground up. And now polynomials can make for very big numbers in terms of calculating resources, but they're at least theoretically tractable. Another set of problems where the NP problems are ones where you already have the solution and you only need a polynomial set of resources to verify if that solution is true. The question of P versus NP is, are these the two same questions? Are they the two classes, that is to say? Generally speaking, it is believed they are not. We should all hope they are not, because if it is proven that P equals NP, then computer security ceases to exist. The codes that you use to pay your bills on computer lines depend on the idea that factoring of prime numbers is an intractable problem. It's solvable in theory. It's important for computer security, excuse me, that it be unsolvable in fact. So but again, these measures of complexities are measures of our theories. Polynomials, not realities. Solutions to theories, not processes in the world. But now, having mentioned this issue, I also want to say that it's quite possible that the only important part of this question is that it be mentioned and acknowledged. Once we understand the problem, I'm not sure it matters where we place our coin, whether we remain pure objectivists and say, no, complexity really is out in the world, or we agree that complexity is primarily a matter of theory. I'm not sure once we acknowledge the problem that it matters, because the simple fact, and this is an objective fact, the only metric of complexity that we have is the complexity of our theories. That's the only thing that's the only place where we can actually measure complexity. So it's always and only our theories where we're measuring the complexity, regardless of whether we're saying that complexity is in some sense an absolute reflection of reality, or simply an abstraction of an emergent quality of our abstractions from reality in our attempts to characterize reality. The question of whether it's objective or theoretic, epistemological, ceases to matter to me, because like I say, the only place we can measure it is our theory. Which leads me to another postulate. Scientific theories, in order to be scientific, must not only be computable, they must be tractable, at least to some order of approximation. So, for example, calculating the weather is intractable in absolute principle, but out to 5 days, we generally get a pretty good model. So it's to within an order of approximation. It's good enough. There are elements in the theory of complexity which actually give us some measure. So, for example, there's what's known as the traveling salesman problem. A salesman has to visit a variety of towns in his route, and the idea is to have the shortest path that visits every town without repeating itself or bouncing around. So, I mean, what is the shortest path the salesman can follow to visit all of the cities he needs to go to? In theory, this is intractable. It is unsolved. It is solvable mathematically, but it's intractable in terms of being solvable by any polynomial resource. However, with polynomial resources, we can still get within about 95% perfect. So we can almost always come up with a good enough solution for the traveling salesman. Forgive me, I'm not actually sick. This is just my October into November hay fever. But to about 95%, we can get within 5% of a perfect solution. And generally speaking, good enough is just that. It is generally good enough. So, I mean, a scientific theory has to be within at least those kinds of bounds. If it's unsolvable, then that, by the very nature of unsolvability, it means you cannot generate numbers that will allow you to test that theory against the world. So it has to be solvable. And it has to be at least within limits tractable. Because again, if it's completely intractable, then you won't generate any meaningful numbers that can allow you to compare that theory to the world. First order, I mentioned that. Traveling, I mentioned that. And this is still pretty strong, even within, that's still a pretty strong requirement. Now, my own thoughts on this subject are fairly original, but I'm not alone in thinking this. For example, Jaakko Hintikka, toward the end of his life, and I remember seeing some stuff that he published in the journal of the APA's journal, and I can't remember the exact year, but I mean, if you really wanted to, or somebody who actually has a membership can access those journals, could come through, because there's only like one journal published each year. So go back to the last 20 years, because it was certainly after the 2000s. I'll get to Bruce in just a moment. But science is not all there is. And Jaakko Hintikka knew this. And so he was focusing on this idea of computability in building of models. So non as opposed to unscientific approaches, things that jump to mind: poetry, music, art, dance, creativity in general. Computer can predict what's popular, not what's original. And original is not simply random, regardless of what the computer might say. You can program a computer to make random noises. You can program a computer to make popular music, but you cannot, I'm going to postulate, you cannot program a computer to make original music. That's a tough one there, and I might be off, because of course the idea of what is originality is pretty tricky itself. But
Gary, just a brief time warning, so we can fit in our other panelists.
I got a little bit more to say. One more speculation. Recall the chess example. Regardless of folks like John von Neumann and Michael A. Arvid might claim, the brain really is not like a computer. Neural signals are not digital binary square waves. They are what are known as analog sinusoidal waves. In other words, a digital wave is a square wave that goes from 0 to 1. I can't twist around enough, but there's a curve in sinusoidal waves, so that they go, I could get on the camera here. They kind of go like this, and they curve. There's a strong analog component in how the brain works, and this is why, I mean, so the brain is actually more like weather, is more like the water running downhill than it is like a digital computer, which is why human chess players, even the great ones, never play chess the way a computer does. A computer brute forces its way through billions of possible moves. And we've only just recently managed to brute force far enough ahead that our computers will beat grandmasters. But that's not how even a grandmaster plays. They see the chessboard. I mean, they do some calculation along the way, but mostly what they're doing is they're seeing it. And that's not a computer. That's not a logic engine. That's a dynamic process. So if the brain is like the weather rather than the National Weather Service's weather computer, might it solve, quote unquote, solve, as the weather does, problems that cannot strictly be computed? One context for considering these issues is Wigner's classic essay published in 1960, The Unreasonable Effectiveness of Mathematics in Modern Science. So that's where I want to end. Sorry for taking so long.
Thank you, Gary, for that set of very provocative contributions. I'm particularly still thinking and will be thinking about your distinction between complexity as a function of our theories versus reality. So I hope we can return to that during the discussion. Our final panelist is Brian Thomas Swimme. Brian's an evolutionary cosmologist who teaches in the Philosophy, Cosmology, and Consciousness program at California Institute of Integral Studies. Brian's the author of a few books. One of them has been mentioned already, The Universe is a Green Dragon. He's also co-authored a wonderful book called The Universe Story, co-authored with Thomas Berry. And he likes, he's a documentary filmmaker as well. He's made a film called The Journey of the Universe, which I highly recommend. And he's also working on a new series of short films, part of the Human Energy Project, which you can find on YouTube. And I think we're going to get a short sample of that today. Brian, the floor is yours.
Thanks, Matt. And Tim and Randall and Gary. Fabulous stuff. I wanted to say just a few words about Tim Eastman's influence on me already. I say already because I'm only just beginning to study Tim's work. I just, let me say as well that I so appreciate the Cobb Institute focusing on Tim's book and bringing together an amazing array of brilliant minds. It's, I don't know, I feel like I'm part of this, some kind of fabulous historic meeting that could only happen with this technology. But at any rate, as I read Tim's work, picking up on what Gary just said about, being able to see the board if you're a chess master, I think I can feel my IQ go creeping upward as I'm reading his book, struggling to understand. I mean, it's got a long ways to go, but, and let me just say, Tim, my overriding emotion reading this is, as I'm reading, I think, oh, if I were only 22. I mean, the possibilities here for someone like myself just feel immense. I just, God, it's just thrilling. Early on, you quote Raymond Nogar and his way of understanding. He says two kinds of understanding. One is a picture. People want to put together a picture, and then the other is people want a drama. I love that distinction. It reminds me of Jerome Bruner. His way of talking about was paradigmatic, like logical, scientific, and a narrative. So I'm very much in the dramatic narrative camp, at which Nogar also characterizes as people that want to be actively involved. So the picture people want to understand, deeply, and then the dramatic people want to be involved. And I think both are necessary, but I guess I bring up my own orientation. to say that I'm really interested in all of this because I feel that an inadequate cosmic narrative is part of the source of a lot of needless suffering. I think about the suicides, the rising suicides, and the addiction to opioids, and the massive amount of death. It's overwhelming. Now, I don't want to blame everything on an inadequate cosmic narrative, but there's certainly a substantial part. There's something inevitable about starting off with the idea that existence is meaningless, and then ending up in some very strange lives that follow from that. At any rate, Tim's, especially in the latter part of the book, Tim's criticism of the current cosmic narratives is far more detailed than I ever thought of. But that's what I find so exciting. So just to list some of the things he goes into, he sees the cosmic narratives as shackled with metaphysical mistakes like substance thinking, causal closure, deductivism, monologicalism, I made that up, and actualism. Monologicalism is probably not a word, but it's the idea of a single point of view. The reason that struck me so much, Tim, is that that's pretty much my whole life has been that, right? Trying to teach people the story, right? So but all of these are shortcomings. That's why I felt like what a thrill to be if I were just starting out, and to take these criticisms to heart and to find a way to give expression to a richer, fuller, deeper narrative. And I have a start. I want to share with you. It's 5 minutes, as Matt talked about. It's a 5-minute video that takes a stab. It takes a stab at using Tim's tripartite approach to understanding. I'll talk about this a little bit afterwards, but it is this notion of there's 3 ways of knowing. There's the way of numbers, powerful, but I think what's thrilling listening to Gary is just how there are limits to what that can do for us. But we've in the modern period we've sort of collapsed into the idea that it'll lead us everywhere. But so there's the way of numbers, and then there's the way of context, which Tim's way of talking about a humanistic, artistic understanding, and then the way of ultimacy. Monica Duras Bowles, that I wrote the script for what you're about to see, and she would be here. She's been here throughout the seminar, but she had a medical emergency in her family. But I know she would want me to say that I want you to hear, before you look at this, that our audience for this is like a curious 20-year-old. So it's the idea of taking some of these like amazingly sophisticated ideas that so many of you are working with and deepening, taking those ideas and trying to find some kind of like an echo in a video that could start the process for a person to enter into a different kind of universe. So maybe Matt, if you could just show that, then I'd come back and give you a few final thoughts. Oh yeah, just imagine you're like 20 again, all right? Try to experience this as if you're 20. I think you'd be more forgiving about how hard it is to convey sophisticated ideas. So this is as opposed to that book you were referring to, Tim, that was 900 pages long. And so like we're trying to go to the YouTube generation, the short attention span. So 5 minutes to them, they told me that was way too long. Can't be more than 2 minutes. Here we go. Are we just a meaningless speck in the midst of a trillion galaxies? Or are we here to construct a planetary mind? Similar questions have haunted humans from the beginning. In this video, we'll be discussing one of the most fascinating speculations that comes from the world of science. I have to warn you in advance, this idea will ask you to stretch your mind. But it suggests a radical new understanding of our existence as humans, one I think you'll enjoy considering. In this episode, we examine how a planetary and even cosmic sense of mentality began to emerge in the classical age of humanity. The breakthrough took place in southern Italy when Pythagoras and other Greek philosophers made the metaphysical assertion that the cosmos is composed of number. Legend has it that this daring speculation came from a remarkable discovery by musicians concerning the quality of sound their instruments created. With respect to a Greek lyre, what matters was the ratios of the string lengths. If the ratios were right, the sound coming forth was music. If they weren't right, it would be nothing but noise. The Pythagoreans leapt from this discovery to the idea that the harmonious movements of the stars and planets come from their being constructed with the right mathematical ratios. This was a wild speculation that mathematics was the foundation of the world, but it launched an investigation we now call mathematical physics. Our trips to the moon, our skyscrapers, our electronic communication technology all follow from that ancient intuition that numbers structure the universe. And this investigation continues even 2.5 millennia after Pythagoras. To hear the latest speculation, we go to the work of Paul Dirac, a Nobel Prize-winning physicist and a founder of quantum field theory. I've already warned you that this speculation is wild, but here we go. Dirac compared the strength of electricity to the strength of gravity and found it to be an extraordinarily large number, 10 raised to the 40th power. Then, when he calculated the number of elementary particles in the entire universe, he found that same number, 10 to the 40th, now squared. When he examined ratios of other processes, he kept coming upon the same number, which convinced him he had stumbled upon a fundamental order. The climax came when he considered the age of the universe. The way we think of it is 14 billion years, but a year is not a universal unit of time. If we go back before there was an Earth and a Sun, the concept of year has no real meaning. Physicists employ a universal unit of time. The interval of time light requires to cross the diameter of an elementary particle. This is called a jiffy. When Dirac calculated the age of the universe in these universal units, he found that in jiffies, the age of the universe is approximately 10 to the 40th. That the age of the universe was this same number stunned Dirac. After all, unlike the ratio of electricity and gravity, the age of the universe is changing. Was it a simple accident that Dirac happened to calculate the age of the universe when the universal time was 10 to the 40th? No, it was not a coincidence. As one of his colleagues pointed out, 10 to the 40th jiffies is not an abstract time. It is the time when the universe had complexified enough to determine its age. This complexification was possible only because in every concrete event, the universe as a whole preserved these special ratios among its fundamental processes. Pythagoras hypothesized that the right ratios between things generate music. Dirac now hypothesized that the right ratios among cosmic powers generate conscious self-awareness. The wild new speculation is that the universe maintains the ratios necessary to become aware of itself. None of this is proof. It is all speculation. But if this speculation turns out to be realistic, it suggests that human mentality is as fundamental to the universe as the stars. It suggests that in our work of building a planetary mind, we are participating with a universe that was mind-like from the beginning. We are not a fluke. We are not an accident. We are part of the self-awakening universe. Okay, great. Thanks for making that work. Just a final, I just want to, well, I guess it's obvious the way of numbers is present there with picking up on Dirac's so-called large numbers hypothesis. But I also wanted to point out that the way of context that Tim is affirming comes from, even though it's not mentioned explicitly, it comes from the new theory of experience created by Wolfgang Leithold. I didn't know he was going to be here. Wolfgang, I don't know if you're still here, but it's great that you checked in. Wolfgang's theory is about the different kinds, qualitatively different kinds of human experience evolved over time. And the one that he calls order emerged during the classical period. And then finally, at the level of ultimacy, the way in which Monica and I were thinking about this is coming out of the realm of Taoism. Taoism had the sense of the cosmic triad of heaven, earth, and human, and that these were dependent upon each other, in a sense that, and this is from Mary Evelyn Tucker's interpretation, that humanity, in this sense, completes heaven and earth. So it would be the Taoist insight into the cosmic significance of the human species. So, and I want to end then with one last quotation from Tim. It's very short, but I just wanted to end with it because I'm if I were a young professor like Matt Segall and others of you, this would become central to my whole research program. So it is this. Tim writes, the Logoi framework is very much undeveloped as a comprehensive narrative. It's just sitting there, right? It's low-hanging fruit for anyone who approaches this task of creating a cosmic narrative. So tremendous work, Tim. I just thrilled to be part of it. Thanks.
Thanks so much, Brian, for bringing the dramatic flair to these conversations and sharing this little piece of the work that you're doing now. So at this point, we can hear from Tim if you'd like in response to any of the panelists. And then in our remaining time, we are going to open it up for dialogue from the rest of our participants.
Well, thank you, Brian, for sharing those thoughts and for connecting it to the different perspectives that I had introduced. And so there's so much to be done. But I'm honored by that the suggestion there. But there's so much that goes way beyond me, and so much that so much should be done. As again, I focus especially on approximation and limitation and finite, the finite capabilities of just the numbers narrative, and the way of context and ultimate context it's so important that we then work with how to call attention to those aspects of ways of knowing more effectively. And I do come back in chapter 8 to emphasize the notion of ultimate context and how, in my struggle with the notion of meaning. And I think I acknowledge how the great work you've done to help recenter ourselves on the notion of meaning and human meaning as being really important. Thank you for that.
So unless any of the other panelists want to chime in, let's open it up. You'll have to forgive me, anyone who had put questions in the chat. I had to reload my Zoom in order to get the video to play a moment ago. So I lost those prior chats. So if you do have a question, please feel free to chime in. You can either use the raise hand function or drop a note in the chat and we can unmute you. Any takers? Kevin Clark. Let's see, ask to unmute. There you go.
Thank you, Matt. Could I share my screen? I have my question written on the paper. Could I share my screen and then I can people can read the question? Is that okay?
You can share, Kevin, if you need to.
Okay, first I want to thank Tim, of course, like everyone else, for a very provocative book. And I want to say quickly that a long time ago, Gary Nelson and I put on a one-day mini conference about category theory in Claremont in 2010. And since then, the fields of philosophy and or metaphysics and or physics have not been overtaken by the use of category theory, although it is essential for relational realism and Zephyrus's understanding of non-local effects through sheaves. But we really feel that it's important, and Tim does too. In chapter 6 on pages 206 and 7, and back in chapter 4, you discuss the importance of an algebra of relations category theory for your logoi perspective. In both places, you present the very same 3-paragraph quote from a short paper by Heather and Rossiter that describes, as your logoi perspective does, the universe as process. But with category theory, the highest structure is the topos, the arrow, which contains a multiplicity of identity arrows. Process is representable as the arrow and is useful for conceiving a fundamental process succession and including prehension and concrescence in this article. And then back in chapter 4, you relate category theory to Whitehead's concept of prehension as generating the mathematical function, the many-to-one relations for understanding causation. And here, just before you quote H and R, you refer to Lucretius's famous poem, which, according to Brian, is a picture, which provide, rather than a narrative, but the poem may be the narrative, I'm not sure, provides the imagery of atoms in the void, which provided the fundamental precursor for the materialistic atomistic theory, which has been the foundation of the Newtonian era. So Tim, I understand that you set Lucretius's atoms in the void in stark relief to category theory's universe as process, the topos as arrow, and process succession, because you feel category theory needs to replace Lucretius's imagery and to be involved at the fundamental level in your logoi perspective. So I'm putting in a plug for category theory here. Since your category theory account in chapter 6 is only 1 page, can you say more about the import of category theory for the logoi and Heather and Rossiter's description of it? And would Professor Heather care to respond?
Well, I encourage Dr. Heather. Michael, could you speak to that question? I think I see that you were on.
Oh, Tim, don't give up so quickly. I want to hear from you too, please.
Yes, of course. But Michael, go ahead.
Well, thank you. I do think that category theory is so important that really we can't make any progress, real progress, unless we operate at the metaphysical language level. There may be other languages, I don't know, but I think theoretically there can only be one, and that is category theory. Of course, it may be represented in other other forms, but formats. But really, I don't think it's this point again about that number is very good at the local level, whereas category theory is needed for global, and that's where all the problems are today. Not all our problems in the world really are now global, of course, and therefore we have to move to such a language. The difficulty, of course, is that there is quite a big learning curve for category theory, but because of its high level, once you get there, it is in fact very, very simple, because it's all there. And also another point is that it is objective, whereas set theory is subjective. It's based on axioms. Whereas if you take the suggestion there that how to define the arrow, you define it as process, and process is the universe. So it's empirically available to us. There's no assumptions. And if you have any assumption in any argument, your conclusions of any inference is suspect, because you might just be reporting what you assume to start with. And that's why I'm so keen on it, because you can do it without any assumptions. And therefore, I do recommend, I don't know quite how, because as I say, it is quite a steep learning curve, mainly because the mind is not ready for it, because we're so wedded to the sort of set theoretic idea. But it's not that difficult, but it is to our minds. It took me really 10 years before I even understood what the free functor was.
Okay. Thank you, Michael, for your comments. I've struggled with understanding category theory, and I'm certainly not there, and I appreciate your expertise with it and your comments, but I appreciate that we now have these new tools to see things in a more fundamental way, and I also philosophically link it to perhaps Jorge Nobo's work in discussing the fundamental notion of succession, relating it to Whitehead's basic conceptuality about that Randall Auxier and Gary formulate in their quantum of explanation, and that in turn has connection with the new fundamental quantum physics. I think there's a connection between all of these, and my apology for being so short with respect to reference to category theory, but as Brian Swimme points out, what I put on the table is just the beginning of so much is needed to flesh this out, and category theory is part of the toolbox to help us flesh things out. Thank you.
Thank you.
Yes, I would like to say also actually that there is a problem in that there are no books, because the pure mathematicians are based on, do their category theory on the category of sets, and they're not proper categories, because a category is, as I said before, it's objective, and a category has got to compose. Numbers do not compose, and sets don't compose. They are therefore models of category theory, and there's not a single book that can be recommended. I mean, there are dozen or so introductions to category theory, and they all come from the set theoretic. And I'm afraid that such books aren't even worth buying as a car boot. So
We need you to write that book.
that's not easy.
Yeah, not easy for sure.
I have great difficulty in writing anything that's not original because I'm wasting my time. And if you write a book, you've always got to put a lot of secondhand stuff in, and I haven't got the patience to spend the time on it, I'm afraid. I prefer to do, work on original thoughts.
Well, thank you, Michael and Kevin, for those questions. Is there anyone else who would like to chime in at this point? I see Jude. Go ahead if you are unmuted, I think. Yep.
This is a totally different direction and is asking for a different kind of speculation, but it's an application of what it looks, what looks to be part of the point of this chapter and the whole project. I just happen to have been reading about some genetic engineering things this recently, and engaging with the thought of how there are research projects that are in this kind of futuristic way, looking at the process of making edits in the human genome for the sake of X, Y, and Z improvements, whether it's disease eradication or personality trait enhancements, et cetera. And without getting into doomsaying about the possibility of tampering with the genetic code, it strikes me, and some of the stuff that is even in your book talks about the way in which the very concept of the genome and the gene, is an area in which we need to apply these sort of different modes of thinking, a more systematic mode of thinking about what it is we're talking about, because these are modes of selecting out things that are alleged particulars in the midst of a more quote unquote complex system, namely the genome or whatever that is, which is all itself selected out for abstract consideration. So all of this to ask, what your thoughts are on the application of the explanatory suggestions and cautions and critiques that you're making in the book as a whole, but particularly this chapter, to things like the project of altering human genetic code, which seems to be something that certain individuals with a lot of wealth are hell-bent on doing one way or another. So I would be curious to hear if you have any kind of quick story to tell about whether cautionary or not about that.
My first reaction is, so to speak, the notion that I attempt to argue for, that with power comes responsibility, with rights comes responsibility, and that I come back to it in chapter 8 and the arguments for the meaning as being an integral part of is somehow, in some sense, real. That I say the real is both the actual and the possible, and that when we flesh out more what that means at multiple levels, and the coupling local global and the interplay between the context independent, the context dependent, and the ultimate context, those factors, then that provides a way to rethink the notion of what a ethical claim or a claim of meaning or whatever, that there's a possible ground for that, not that it's somehow decoupled from, if you just have atoms in the void and just particularism, then you have no way of understanding the basis for a ethical claim or a religious claim. But so I sort of took a whole new approach to understanding, well, some basis in the world for the reality in some sense, in the broad reality, both actual and the possible, for the meaningfulness of meaning and of the ethical considerations. And certainly then in this genetic development, then we make choices, and those choices have an impact, and there's an ethical dimension to that that's real, and we intuit that, so to speak, but we often we have difficulty. How do we then translate that intuition into some scientific language and so forth? Well, part of that is that we abstract out of it to get models that then those models can't accommodate, such claims. Well, we need to appreciate that there's more to reality than just our science. That's scientism. That the world really is at multiple levels and incorporates context dependence and incorporates linkages to the spiritual dimension. I claim that these are real and that there's arguments to be made for why they're real, and that those ethical considerations are important. And so yeah, yes, so we make fateful choices now about, and often we avoid those fateful choices by indulging in context denialism, whether that context denialism is denialism about climate change or denialism about our responsibility, that then we make choices that are exceeding short-term or based just on profit or based upon some abstraction for immediate self-interest or short-term self-interest in denial of the long-term implications. So I think you can think of your own examples of context denialism, but it so permeates our present culture, political and otherwise, as excuses for focusing on the what benefits just me and some limited context in denial of the longer range implications of things. So yeah,
I was going to just clarify, because I left out of how I asked that, the background thinking, which is that at the theoretical level, what projects like that seem to be influenced by is a certain narrative understanding of evolution, what we mean by that as a concept, and its theoretical and predictive value in how humans tend to think anticipatorily, to use one of the terms in your text. And so it operates sometimes, some geneticists, wonder about it operating at a narrative level that influences those kinds of decision making that isn't necessarily particularly good science, right?
Yeah.
That there's this modeling or taking of evolution to mean certain things, which is adapting to certain circumstances, et cetera. But it isn't just that. But if we use it that way, it has, and using it that way is an instance of this kind of particularism and context denialism that you were just talking about. So part of what I'm wondering about is your thought about that theoretical construction of these questions and less the moral issue of it.
Oh, yes. Well, you refer to evolution, and I'm not a biologist or an evolutionary theorist, but I'm struck with how the standard readings of evolution tend to characterize the development of new organisms, of new possibilities in pure chance, pure flip in the coin. And of course, new developments in anticipatory complex systems and anticipatory dynamics and so forth take us a step beyond that kind of very limited understanding of even evolution, and so to speak, a standard model of evolution. It needs yet to be superseded by some new biophilosophy, as Spiridon Kotrafidis and Terence Deacon and others have been working with. So I'm hoping in the coming century that we will come to a better appreciation of of an enhanced evolutionary theory that gets beyond the 18th century metaphysics that's currently embedded with it, and the particularism and the chance only kind of thing, but yet in a way that, well, of course, defenders of standard evolution, then they point to the other extreme, right? The extreme of simplistic creationism. But in my argument, I would say that, so to speak, at the fundamental level, there's, so to speak, the incorporation of new possibilities, ingredient in every quantum process at multiple levels. That to me is the deep creationality of the universe at multiple levels. And so to speak, creationism is a denial of creation, because we're putting out the creation only to a isolated transcendent entity, and everything else is radically mechanistic, which is a denial of creation. Whereas research in biology is revealing all kinds of ways in which creation is right there in front of us at multiple levels. So good research in biology is, in our lived lives, are radically pro-creation, and creationism is radically anti-creation. How about that for irony?
Thanks, Tim.
Yeah, well said, Tim. Thanks for that question, Jude. I think we have time for one more. Did Gary Nelson did you have your hand up, Gary, earlier? Let's unmute you here.
Myself, okay, I'm
There you go.
yeah, I have Goldblatt's book here, and he refers. The reason I was impressed by this was that the very statement at the end here, he says, the role of set theory as the lingua universalis for mathematical foundations will be a declining one in the years to come. And he expounds on that. So this is the only book that I've found useful, but I'm no expert in category theory, but it seems to me that it's a really big deal, and that it is intruding its way into the foundations of math and science. Am I mistaken, Michael?
Well, Goldblatt's a difficult book to read. I take my hat off to you if you're able to understand it, really. I mean, all these things are so cluttered with set theory. That's what makes it also complicated, unnecessarily complicated. But certainly that conclusion that you quote is spot on.
Oh, okay.
Well, thanks for the book recommendation. I certainly need a way to get into category theory more deeply, but it sounds like this particular text may make it even more difficult. We have one final question from Wolfgang. Let's make sure you can unmute, and please. Here you go.
Yeah, thank you. I would like to, can you hear me?
Yes, thank you.
Okay. Yeah, thank you. I would like to take up again your key notion of process and reality, and sort of sidestep to the remark of Brian about participation. When you look at the history of human experience, it took quite many thousand and 100,000 of years until the idea of participation became popular. That only starts with the Mesolithic. In former times, you don't have any idea of participation represented in what we have as artwork from the Paleolithic. But from the Mesolithic onward, something occurs that we today call mythology. And mythology is basically interested in time and creation. Most mythological stories are about the process of reality over time. It starts with creation, and then it goes on and on, step by step. That's what Brian and we are both very much interested in. So time is one of the core notions of mythology. Then when you go to what I call the noetic turn, that is the start of philosophical reasoning, of rationality, you are facing a totally different approach to the order of reality. And that is a linguistic side remark that I would like to make, because the entire history of metaphysics is sort of rotating around the key notion of being. And the interesting part in the role that being is playing in our mindset from antiquity onward is that being is an infinitive of the present. So the entire metaphysics is a metaphysics of the present, which makes it very difficult to develop an adequate idea of process, because process always involves past and future. But in the perspective of the tradition of metaphysics, the past and future is always something that is not being, a non-being entity. That means it is not an entity at all. And so one of the problems that you quite adequately deal with, and Whitehead has done, is how to get away from that old idea that the key notion of metaphysics and of the structure of reality is being, which is sort of focused on the present only. So the step that we have to do is to put time again in the center of our reasoning. So not starting with the theory of being, of what is, but of becoming in the sense of what is emerging from the flux of time. And I think, and that is my question. I've put it from perspective, and that is a metaphysical, history of my mind. Try to link it up to your Tim's ideas that you present in your book. Is that going into the same direction, or am I just talking nonsense?
Oh no, I agree. I agree entirely. A good point. That is that there's historically in the history of thought, there's been a tendency to start from, so to speak, expressions of the immediacy of experience, and then as rationality developed and efforts to articulate that in language, a tendency to focus on the notion of being, which we then have in terms of the standard ontologies over the last number of centuries. And in the last century, only quite recently, a recognition that we need to go beyond that to being and becoming, that becoming and process are important. And now we have new tools in science and philosophy to argue the importance of that element of fundamental process and of becoming, which I'm trying to articulate in what I've done with my Logoi framework, of course, with Whitehead had it in his own way and so forth. I think that the issue about time, I think what's fundamental is, so to speak, the becoming and process, and that what we usually would use the word time and space are, so to speak, emergent from the fundamental process. So we need to be careful in how we're using the term, the word time. And by seeing it as emergent, then that's a way to incorporate both attention to the immediacy of experience and the present, but also anticipation of the future and the combination of the present immediacy and possibility, so to speak. The real is both the possible and the actual. And so the real is more than just the immediate actualizations, which is, so to speak, the present. The real is much more inclusive. And I think that then ultimately answers your point about how we got stuck for many centuries in focusing on being and just the present. That was a particular way of degrading the notion of possibility. But now, I think we now have new tools to recognize the importance of in a fundamental way, and I hypothesize them as being metaphysically fundamental as distinct orders, the order of potentia, the order of actualization. To take those as fundamental in the domain of the real inclusively is a way to affirm what your point you're making, that then from here going forward, we should see in not just anticipatory manner, anticipatory dynamic matter, but fundamentally that we have, in a way, possibilities for tapping into the domain of possibility in ways that are more than just simply choice, that there's a connectivity at multiple levels that are of the mind brain. We'll be talking more about this, but thank you.
Yes, thank you, Wolfgang, for bringing in that perspective on the importance of time, or becoming, as Tim was hinting. The language here is slippery, and time as a metric, at least, would be emergent from these more fundamental processes. So unfortunately, our time is up. Actually, we've gone about 7 minutes over. So I appreciate everyone sticking with us to bring this complex whole of a dialogue to completion. We will